Hello YouTube, this is George with the G&M Homes Movies channel. Today's video is about upgrading to a heat pump water heater. This is our old original electric water heater, and I ordered a Rheem Performance Platinum 40-gallon hybrid high efficiency smart electric water heater. That's a mouthful. But anyway, it's going to be delivered this afternoon. I paid for extra shipping where the delivery drivers will bring it into the house and unpack it. And I'm also hoping that they will help me set it up on the little platform I built, because the thing weighs 157 pounds, so it's a beast. So I wanted to do a few things ahead of time before the new water heater is delivered. I stacked up some of those concrete pavers there to make a little platform. I don't really want the thing to be sitting right on the floor. And I put the drain pan down. I struggled with how to plumb the drain pan because there's a floor drain over there in the corner, but it's already crowded with the water heater overflow, the condensate pipe from the air conditioner, and the drain for the existing water heater. So what I decided to do was just to plumb the new one into the old one and hope for the best. So my grand plan is to install the new heat pump water heater and then try to convert the old one into a dump load and to preheat water and then plumb it into the new one. Right. Wow, that's big. Okay. Yeah.
The paper for instruction installation.
Okay.
Right?
I will read
the
that.
video well.
I have to rethink my drain strategy because this device has a condensate drain, because it is an air conditioner after all. And it also has a pressure relief valve and then the drain pan itself. So it's three things that I have to drain off of this water heater. So that's going to be a tight fit. It's got this extra thing called the CTA adapter. It must be connected to the line voltage as detailed in the CTA adapter wiring section. So I just did some quick research and found out that the CTA adapter, I still don't know what CTA stands for, but it allows the water heater to communicate with the utility to participate in a peak demand type power saving. Because it's so tight in here, what I'm going to do is I'm going to put an electrical box on top here. The wires are long enough to get into a box, and that'll give me a little bit more room to make the connection to the wire. So I just got back from one which I'm sure will be one of many trips to the hardware store. So I got a nice box to go in there, and that should work out good. $75 worth of wire. Stuff is expensive. So what I'm going to do is I'm going to drill some holes underneath on the bottom of this box. That way I'll attach the box and the original cover all at the same time. There we go. That's pretty good. So I have this 3/4 inch liquid tight plastic conduit, and this is actually left over from another project. I'm going to run a piece of this flex tight over to the wall and up here. Actually, I already had a couple pieces cut, so I'm going to use them instead. Now there's a filter back here. I got to make sure I have access to that. So I'm going to run the wire out of the back of the box like that. And that way it won't interfere with the filter. Alright, so I got my loyal assistant to help me here. And we got a crazy puppy. There's going to be some noise. So this wire is way up there behind this ductwork. So I'm going to use these little clamps and some short wood screws to secure to the bottom of the rafters. Getting that wire run up there was a challenge. There were so many obstructions, ductwork, other wires and water pipes, communication cables. But it's there. Not the prettiest job I've ever done, but it'll work. So now I'm going to get it into the panel, and this is a sub panel, which means it has a separate ground bus bar and a separate neutral bus bar. They're two separate things, whereas in the main panel, they're combined to a single bus bar. Also, this panel is getting crowded. It's getting busy. I got a 30-amp breaker that's going to go right in there for the water heater. This way. This way. Alright, so that's it. So I can't turn it on because the tank's got to be full of water before I turn it on. Print a label for that. I'll set this one. Alright, so electrical is done. So another change of plans. This drain down here, I did some investigation, and the condensation from the air conditioning system currently flows into that drain, and last summer it overflowed and backed up, and there's water all over the basement. So I did a little bit of investigation. Off camera, I stuck a drain cleaning fish tape down in there, and the first thing I noticed is there is no trap. I never smelled sewer gas, so I know it's not connected to the septic tank. It's just an elbow, and so I was able to put the fish tape down there for 15 feet that way, but it's only 13 feet from here to that wall, and these are 12-inch block, so it means the pipe goes out a foot beyond the foundation, and that was a dead end. I couldn't get it to go any further than that. Also, I built this rig, and I filled it up with water, and I was able to pump a full tank of water, it's probably 20 to 30 gallons of water into it, and it took it. It didn't back up. But since I don't know where the water is going, I doubt that there's a sump or a French drain or anything like that. So I suspect it's just going into the dirt out in front of the foundation, and that's not good. So the change of plan is I'm still going to use the floor drain for the drain pan and for the overflow or the pressure release valve, but for the condensation, I'm going to plumb that around that way and go behind the furnace / air conditioner system, and I'm going to buy and install a condensation pump to deal with both the condensation from the air conditioner and from the water heater. So this condensation pump is installed. I got the drain for the air conditioner hooked up. I use this 1/2-inch PEX to run over to a utility tub in the other room. And I use a hose fitting here because the instructions say you got to clean it frequently, so I wanted to be able to easily disconnect it. So this is a big day. And we're going to cut over to the new water heater. So I pre-made some of my fittings. I'm using 3/4 inch PEX for most of this. And I'm using these flexible stainless steel connectors for the rest of it. These have plastic washers in there, so it's good for preventing the heat from escaping and becoming a radiator. So the first thing I'm going to do is shut off the electric to the old water heater and turn off all the water. I'm going to install the cold water first so I can turn that back on so we can at least flush the toilets, then hook up the rest of it. So yesterday I installed the pressure relief over temperature, over pressure pipe. For this I used 3/4 inch copper and old-fashioned solder connectors. I figure if this thing ever does let loose, it's going to be scalding hot water, so I felt better using copper on that. All right, so let's get into it. Water heater is off. So I have these manifolds for the water distribution. Installed that a number of years ago when we remodeled the kitchen and then remodeled the bathrooms. So I'm going to go ahead and turn these all off. So this is the cold water inlet to the old water heater. Turn that off. This is the water filter. It has an off valve on that. Well, I had a bit of a disaster. I couldn't get the cold water line back onto the manifold because I think I made it just a fraction of an inch too long. So I did manage to loosen up all the screws that are supporting the thing, got enough wiggle room to get it in there. I'm going to have to definitely check for leaks when I turn the water back on. So I got a leak right here. So it means I got to replace this whole part from the water filter out. And I don't have enough fittings on hand, so I got to make an emergency run to Home Depot. I'm starting to have second thoughts about sharing this video. This will be my second attempt to cut over to the new water heater. I just been creating one problem after another. So when I originally tried to install the new components, I had a leak. It was in a bad place, so I had to take all this out and replace it. And so I did that, and I reinstalled my new fittings. And now I got 3 leaks. I got a leak right here where the PEX meets the white PVC. I tried tightening it up a couple times, but it still keeps leaking. And I got a leak right here, and then I got another leak down here. I don't know how this one came about because I didn't even touch this fitting. Maybe it was there all along. So, but what I've noticed is that all these 3 leaks are all threaded fittings. And my PEX crimp fittings, they're fine. They're solid as can be. So I'm going to take it all out again and do it over. So this will be the 3rd time I'm trying to connect the new stuff and the 2nd time I'm rebuilding the whole thing. But this time I'm going to use PEX everywhere, from here all the way out, and minimize the number of connections. So I went back to the home center, spent another $138, got more fittings. So I got these couplers because they already have the PEX part fit in, or installed, so that'll eliminate 4 threaded fittings. So I'm going to minimize the amount of threaded fittings so that hopefully have no more leaks. So I'm going to shut off the old water heater, shut the water off. I pre-made as many things as I can to minimize the downtime on the water. And then I'm going to take it all out and start over. Alright, so all the old leaky stuff is out, and I'm going to start measuring and cutting and installing the new parts. So I pre-assembled some parts. This is going to go in here. I'm going to try some of this expensive Teflon tape. As I mentioned, all my leaks were in the threaded fittings. So rather than using the cheap Teflon tape, I'm going to try this stuff, which was $4.40, I think, like that. Where the other stuff was like 98 cents. Alright, so the first new fitting is in. I originally constructed this and sized it off for 3/4 inch white PVC pipe like this stuff. The PEX is just a little smaller diameter. So I made these adapters so that when I clamp it in, it'll still line up in the right place. Alright, fitting number 2 installed. Alright, so that one's out. I'm gonna loosen this up, see if it'll give me more wiggle room. Alright, so final crimp. Well, there it is. So I'm going to turn the water on and check for leaks. No leaks so far. So that's good news. That's a big relief. So what I'm going to do now is put the clamps back on, turn on the rest of the cold water valves, and then I'll be ready to work on the hot water stuff. So I really like this PEX plumbing. It works very well. About 10 years ago, I ripped out all the copper pipes out of our house and replaced it with 1/2 inch PEX, these manifolds. Our water is quite acidic, and it was eating out the inside of the copper lines and turns the dog water bowl green and the inside of the toilets green. Alright, cold water is restored, and now I'm going to gear up for the hot water plumbing. The heat pump water heater is installed and up and running. Yesterday, while I was getting to the most exciting parts of hooking it up, my mobile phone ran out of memory and it stopped recording. But I didn't want to stop working, so I went ahead and finished the installation, and I'll tell you about it now. So the plumbing all worked out pretty well. Maybe I can reclaim my DIY credibility. So it's all put together and there's no leaks. So far with the new water heater, we did 2 showers and a load of dishes in the dishwasher, and it did well. I didn't hear it run that much. The water's nice and hot. It has different modes, and I'm using the energy saver mode, which is the mode that they developed to get it what do you call it? Energy Star. Yeah, so it's Energy Star certified in the energy saver mode. All right, so that turned out pretty good. So the new water heater is running. There's cold air coming out there because it's essentially air conditioning the basement, sucking heat out of the basement air to heat the water, and consequently cold air is coming out. So that'll be nice for the summertime. Might not be so good in the wintertime. So it's been about 10 days since I cut over to the heat pump water heater. And it's working very well. Showers, the dishwasher, wash machine, general cleaning. So we got plenty of hot water, and it works very well. In fact, this water heater is extremely efficient. I have it hooked up to the solar electric system, and I barely noticed a bump in the load. I probably can't see it, but this blue line here is the load. Now, May the 13th is the day I cut over, and there's a bit of a spike on that day, and that's why I think, because had to initially heat up all the water, so I think that was an extra long day, and also the day before it rained, so the battery had to get charged up. But like I said, barely any increase. Fact, it looks like it's on a downward trend. So it's very efficient, uses very little energy, produces nice hot water, quiet, hardly ever hear it run. But here's a big change in plan. So because this thing is so efficient and it runs so well on the solar power, I am going to give up on my dump load preheat thing using the old water heater, because I don't need the preheat. I mean, I don't need it. So I wish I would have figured this out at the beginning, because then I could have just did a simple replacement of this and saved some room, saved money and time, because all these fittings cost money and took time to put in. And I don't yet know what I'm going to do with this thing. For now, it's just going to sit there. So instead of the dump load, I'm going to move over the kitchen wall oven, which draws 3,400 watts. So I'm going to move that over from the grid to the solar electric. And then come next winter, I'm going to move over. Our second floor of our house has electric baseboard heat. So I'm going to move over the baseboard heater in the main bedroom and the main bathroom, and together they're 1,700 watts. So that's what I'm going to do instead of the dump load. I had some notes, but I misplaced them. So money-wise, the water heater itself, with tax and shipping, costs $1,600. I bought the extra shipping to get it so that they can put it in place for me. I spent another $600 in material, electrical and plumbing material. So for a total of $2,200, which is pricey for a water heater, but it's so darn efficient. I think the payback time will be reasonable. I was able to take back some leftover fittings to Home Depot, and I got $85 worth of refund. So I think it's a good investment. I enjoy doing the installation, even though I screwed up a bunch of times. It turned out pretty good. Also, I bought a remote thermometer and got it hanging right there. That way I can keep an eye on temperature. That communicates with my weather station that we have up in the kitchen, so I can see how cold it gets in the basement. It's not bad right now. What else I want to say? Okay, there's an app. It's called the EcoNet app. Took me a bit of fiddling to get it to work, but it works. It's marginally useful. It does show how much hot water is available, whether it's half full or 3/4 full, and it does show when the compressor is running, and it does show how much power the thing uses. I haven't checked it lately, but a couple days after I installed the app, it was like 0.29 kW. So I think that's it. I think it's everything I wanted to cover. I hope you enjoyed this video and found something useful out of it. If you did, give me a big thumbs up, and I will see you the next time I post a random DIY video.